Hello everyone, I am Dattatreya Nikam. Welcome you all on our channel eFunda for new day, new topic. And our today's topic is very interesting, that interview question. And if you are new to our channel, then please note that this will be presented in a parts so as to have a better understanding as well as guidance on the interview related question. And if you are new to our channel, then please visit to our channel eFunda and watch all the videos created various topics of engineering, and same can be seen in our playlist. Also, for our viewers, we have also started our new blog, that is eFunda channel, where one can see the detailed technical discussions as well as article on various technical topic. And don't forget to subscribe to our channel and also press the bell icon to get latest notification on upload of our new video on our channel eFunda. So let's begin with our today's topic, that is interview questions. Question 1. What is transmitter? A transmitter is used to transfer signal from one point to other location. Example, transfer signal from field to remote monitoring location at the control room. Type of transmitters are conventional pneumatic type or a smart electronic type transmitter. One can refer to the figures where one can see the difference between two transmitter types, and further can be discussed in this series to understand better. The function of an electronic device which is locally installed at a field near tapping point to measure a physical variable such as a temperature, pressure, and produces a very low level electronic signal as a result. The transmitter gives output in 4 to 20 milliamp for remote monitoring at a control room by operator. Question 2. What is a smart transmitter? Smart transmitter is a single modular auto ranging remote transducer. Little bit difficult to remember, but by practice you will be remembering as you are practicing on or working on this such type of devices. One can refer to the pictures where conventional transmitter and smart transmitters are shown for better understanding. It is an intelligent transmitter that has an analog output and simultaneously provides a digital communication signal which is based on HART protocol or a foundation field bus or a Profibus for diagnostic purposes. Transmitter functionality and installation. One can refer to the closed loop where FE, FT, FC, FY, FCVs are shown, and similarly one can refer to the other figure where typically transmitter is installed with the help of tapping stanchion or a mounting stand so as to have the correct installation of a transmitter at the field location. Simultaneously, one can refer to the picture where the exact installation of a transmitter is shown in the field. One can refer to the picture from Emerson transmitter where process isolation valve, that is a low valve, needs to be fully open. Process isolation high side valve needs to be fully open. In the center one can see the equalization valve needs to be fully closed. Valve manifold, one can see the small picture. Simultaneously into the another picture where one can see the electronic transmitter body, that is a flow transmitter, need to be correctly installed. Then below flow transmitter where low pressure side to be connected to the downstream of the line, as well as flow transmitter high, that is a HP side, to be connected to the upstream. This is how the installation of a flow transmitter is done in the field. Now we will see the components and their functionality. One can refer to the chart where sensor here is orifice plate. Orifice plate functionality is a sensing, that is a sizing and selection, that is a beta ratio is equals to small d by capital D ratio, and installation of a orifice identifying upstream and downstream location, that means flow direction will be marked on a line. Transmitter converting or transmitting the high pressure side of the flow transmitter needs to be connected to the upstream of the site so as to have the differential pressure across orifice and measured by the flow transmitter, that is a DP type flow transmitter. Controller, which is used to compare, calculate and correct the action. Transducer, that is the I2P, converting the signal time from current to pressure. Final control element is the manipulating impulse line. The impulse line from the tapping in orifice flanges to the flow transmitter. Valve manifold, the process isolation valve, equalization valve in the manifold, and the transmitter can read the differential pressure correctly. Question 3. Why is 4 to 20 signal preferred over a 0 to 20 milliamp signal? The output of a transmitter is a 4 to 20 milliamp as a standard signal, which represent a 4 milliamp as a lower value and 20 milliamp higher value, and this signal supports two-wire transmission that supplies power needed for loop power devices like transmitter and display to operator. One can refer to the picture from instrumentationtools.com where they have shown the animation how the current is flown from controller or a control system to the transmitter, and from transmitter the return signal is connected to the pair cable to the control system with the help of conversion of A to D converter and 250 ohm resistance. It sends an analog signal from 4 to 20 milliamp that represent 0 to 100% of some process variable. By this signal, easy to identify zero value is a transmitter is faulty or loss of signal, which represent zero value. Hence, 0 to 20 milliamp is not preferred over 4 to 20 milliamp signal, as this signal requires to read remotely at the CPU or DCS control system need to convert an analog signal into digital in the range of 1 to 5 volt, which is compatible to the DCS or PLC analog input card. For this conversion, it requires 250 ohm and complete the calculation as shown in the table. Refer the table where Ohm's law is equals to V is equals to IR, where we know the voltage, we know the resistance, we need to calculate the value of I. First case, voltage level is 1 volt, so I is equals to V by R, where 1 by 250, that is a 250 ohm, calculations comes is 4 milliamps. Simultaneously into the case 2 where voltage level is a 5 volt, I is equals to V by R, so I is equals to 5 voltage level to 250 ohm divided, then the calculation or answer comes as the current is a 20 milliamp. This is how the 4 to 20 milliamp signal is preferred over 0 to 20 milliamp signal, and how the current is from field to the control room is carried without dropping of any current. Fourth question, difference between 2-wire, 3-wire and 4-wire transmitter. First, power and signal are transmitted via a single common cable into a 2-wire transmitter. Second, the data signal and power in a 3-wire are always proportional to the common ground. Third, 2-wire are used for power supply and 2 separate ones for signal in a 4-wire transmitter combination. Fifth question, how do you calibrate a DP transmitter? When calibrating a DP transmitter, the following steps must be taken. Before that, one can refer to the picture below where HART communicator is connected to flow transmitter, that is a DP type, and pressure calibrator is being used, and HPLP connections are shown, and further 2-wire from DCS PLC SCADA systems are coming to the transmitter, and same wires will carry power from DCS PLC SCADA system as well as the signal from field to the control system, that is a 4 to 20 milliamps. Set 0 to transmitter, Second, static pressure test. Apply the same amount of pressure to both sides of the transmitter. Zero should not move. If it's shifting, perform static alignment. Here in this setup, we have kept LP side as a open and HP is connected to the pressure calibrator so as to see whether we are getting the differentials or not. And once you got the confirm the differentials are coming, then you can do this test as well. Vacuum test. Apply equal vacuum pressure to both sides. The zero should not be moved. This is how the transmitter calibration is done, where one has to ensure that the zero value of the transmitter is being set, and for that one should understand how the heart calibrator or communicator is being used so as to see the actual zero setting of the transmitter. With this, we are concluding on our today's topic, and you can find our channel details as follows. If you are new to our channel, that is our YouTube channel eFunda, then subscribe to our channel eFunda and don't forget to press bell icon to get latest notification of upload of our new video on our channel eFunda. Similarly, you can follow us on a Instagram page. Similarly, you can follow us on our Facebook page as well. And keep watching our channel eFunda for various topics related to engineering and a project. With this, we can assure you this will help you to better your understanding on engineering and a project topic. Keep watching our channel eFunda. Thanks. Watch our channel for new day, new topic.